Under high vacuum at negative 400 degrees Fahrenheit, ultraviolet irradiation of gas mixture consisting of H2O, carbon dioxide, carbon monoxide, and a couple of other elements, or compounds, excuse me, deposited onto an aluminum surface, transmuted all by themselves, these are just compounds, into 16 amino acids that were stable at room temperature. This is literally taking chemicals and building the building blocks for making you and me. Even with amino acids destroying, even in an amino acid destroying carbon dioxide and nitrogen atmosphere, you can find products rich in amino acids with the addition of iron and carbonate material on the surface of a planet, asteroid, or a moon. Even more of them can be found if you get carbon dioxide, nitrogen, hydrogen sulfide, and sulfur dioxide in a volcanic atmosphere. You can also test this at the bottom of the ocean with just those compounds coming out of a plume, forming them as a slime on the surface of the stones right near them. This happens under conditions that break down these things, but if you give them the right materials and gases, it happens. There was an experiment involving a 500 milliliter flask half full of water and heated to induce evaporation, and allowed to enter a larger sterilized 2-liter glass flask. This is water vapor that would also be sterilized. With water, methane, and ammonia and hydrogen all sealed inside, and continuous electrical sparks fired between the electrodes to simulate lightning in the water vapor and gas mixture atmosphere. And then the simulated atmosphere was cooled again so that the water condensed and trickled onto a U-shaped trap at the bottom of the apparatus, where it all linked up all by itself under those conditions with the addition of electrostatic charges or lightning under lab conditions, and produced well over 20 different amino acids spontaneously. In 1952, amino acids formed from compounds, not from life, in sterilized conditions, and this has been reproduced. 1961, Joan Oro showed that a large quantity of adenine, which is one of the four, well, actually five, but one of the four base pair compounds that is found in DNA, could be formed in mass from polymerization of ammonia with 5 hydrogen cyanide molecules in aqueous solution. That's hydrogen cyanide and ammonia in water. Just synthesizing it. In fact, it was done with ultraviolet light, most likely. Other experiments showed that this could work in a vacuum of space. I did mention, by the way, again, at a near vacuum or high vacuum at 440 degrees below zero with ultraviolet radiation, gases that come out of a star condensing would form amino acids in vacuum. Just need to be heated up again. But that never happens in space, right? Number 4, I can't pronounce it, and I can't pronounce it, is an amino acid residue that has, is a amino acid residue complex of 62 amino acids that forms the smallest enzyme subunit reported to date. And it has a habit of self-assembling and just become much more complex shapes like hexagons all by itself. Spontaneous self-assembly. Gila monster saliva 20 amino acid TRP cage proteins are the smallest modern protein we know of. It's smaller than that enzyme. An enzyme is a protein molecule that works as a biological catalyst in cells without itself being consumed or destroyed or altered. So it can just keep doing this process, forming a mechanism or a tool almost. The oldest class of proteins were the alpha helic and beta strand molecular fossil proteins. Some are composed of alternating alpha helic and beta strands along the backbone of a protein set, but some of these early proteins consisted entirely of just simple amino acids by themselves, but are now classed as substructural domains, and they're found in proteins, genetic data, that sort of thing. They are considered leftovers from when they were just little pieces, simple things forming complex patterns. And as I've stated, you can do an experiment where you'll get most of, if not all, the building blocks, depending on whether or not you make it a volcanic atmosphere, the vacuum of space itself, or just a storm one night over some rocks with iron and, carbon and sulfur and fire and brimstone. Literally. The development of phototrophic organisms like cyanobacteria and other things that ate light or used light to cause a reaction so that they could get more out of the process rather than just processing the chemicals themselves and getting them to react, resulted in a worldwide increase in oxygen that destroyed lots of bacteria that didn't like oxygen. It's an oxidizer. The Great Oxidization Event from 2.5 billion years ago to 0.8 billion years ago. Not million years ago like we have for 65 million years ago from the impactor that killed the dinosaurs. We're talking 2.5 to 0.8 billion years ago. Before that, you had bacteria or other things that didn't use oxygen. But after this, or especially around 300 million years ago, biologically produced molecular oxygen began to poison the atmosphere and kill off all of the anaerobic or abiotic bacteria, enabling the subsequent development of multicellular forms which could exploit oxygen in their processes rather than just using light or just chemical reactions with what was boiling in the seas. This induced certain areas of proteins to change due to oxidization or other characteristics. Some were more prone to undergo changes spontaneously. Others were much more, staid and lazy. Essential genes, as we call them, are responsible for protein architecture, structural, catalytic, metal, cofactor binding centers, or interaction, and tend to be much more unable to change over time, but they still do. They just change less often. The temperature at which various ancient proteins melt was correlated directly with growth temperature optimization for current organisms and previous ones. Plain English, depending on the oxygen level, chemical levels, and depending on changes that kept happening in temperature, pH, everything, things would happen to form these masses of little things that would connect to each other that eventually started behaving like what we now call bacteria and viruses and such. And then the oxygen event happened, and that caused an even more extreme version of it. You could think of them as spontaneously assembling chemical compounds, which you can prove happen, going ahead and becoming things that can replicate. And the thing is, you can put in a long-term experiment and make some of this stuff happen. You have to induce it because you don't want to wait literally a billion years, but you can see this happen. And it's not a stretch or anything, it just takes a long time. And then someone will immediately scream, well, you have to prove it by literally waiting a billion years. Meanwhile, I get to run the country without consent because I'm the Pope. We haven't allowed that for a long time, so we're going to do another part here. I'm going to skip a bunch of stuff here, but the basic idea is temperature and environment caused chemical reactions that would do something simple, like form something that's maybe 20 things long, from something that only formed adenine, guanine, thymine, cytosine, and the other amino acids that I'm not even listing here, that are only just slightly more complicated. One of the amino acids isn't a really complicated chain. In and of itself, it's just 3 or 4 atoms. Well, actually about half a dozen atoms, but 2 or 3 different atoms. Someone said a comment today, but I'm going to poetically relicense this without filling in my little application form. If you don't dread a creator or a lawgiver or a judge and jury of your life, you may laugh at those who would say the following. There aren't enough seconds in the universe since the Big Bang at 1 mutation per second for a single GATC or Gattaca instruction in DNA to form up through a usable protein accidentally, with the necessity of it happening end to end without fail 3.4 billion times as the length of a human genome today. Someone didn't look up some basic math. The age of the universe, which the person refused to acknowledge in this equation, would have destroyed this. Since the Big Bang, the universe has become 13 billion years old. At 3.4 billion DNA sequences, we should come up with a baseline. Now that's 432 quadrillion seconds, or 5 trillion days, or 675 billion weeks. I'm making it a little older, a little younger. We're going to make it a young universe because I don't want to do non-round numbers. So at 6.75 billion weeks, hint, hint, we have to look at the time it takes to synthesize an adenine. One of the 4 building blocks for DNA. We're not even doing the baseline stuff with the other shit. We're just going to do adenine, guanine, thiosin. Adenine, guanine, thiosin, I can't pronounce it. A hydrogen cyanide and ammonia water solution made adenine in a few weeks. No, it's a few days. So let's give it a week. Let's assume the other amino acids emerged eventually, so let's just do it as a 1-week time cycle. And since you're deciding that it has to be from the beginning of the universe, or the beginning of the, beginning of Earth, which is actually about the same timing, so 13 billion years is about right. Okay, now no one is saying that they formed that early, but if you want to give me that much time, I'm going to fucking run with it. Let's do this. At 675 billion weeks to do 3 billion genome sets. What that works out with is around 225 weeks, or 4 years between mutations. Not once per second. A mutation every 4 years. Actually, it's a little longer than that, but we'll just call it 4 years. You decided to do it from the Big Bang, which technically is true because, again, we can do experiments proving that in the gases of stars and some planets outside of them, like gas giants like Jupiter, or the atmosphere above Venus, you do get adenine and guanine and thiosin and the other forming in a day. Even more if you just throw in a little volcanic activity, which doesn't require anything that other than the planet have, lava, okay? So it's not once a second you'd have to have a mutation. If you did this the way you were calculating it poorly, it would take at minimum for 13 billion years to cause a little over 3 billion genome sequences to spontaneously happen in this extremely tinker-toy version of reality. You'd have to have a mutation every 4 years. See also COVID-19 mutating from shit that attacked 2 different types of viruses, which are even simpler than some of these things, that managed to attack a cell, fuse together, and form something evil we're dealing with. That's a mutation pretty quickly. We have viruses and bacteria right now that mutate very rapidly. We have insects that mutate in less than 4 fucking years. Hydrogen cyanide, ammonia water solution made in adenine in a few days. We're going to call it a week to be generous. You said it couldn't happen in 13 billion years because you didn't mention it. And the 3 billion DNA strands we have would take 4 years to have that many mutations happen sequentially, which is what you were using as your rinky-dink math. So the person says, some math equation. Even one instruction in DNA to form a usable protein accidentally. Even though you don't need DNA to form proteins, they can form randomly as amino acid sets. 3.4 billion, the length of the human genome, with the necessity of it happening end to end without fail. They all fail. We see this already. You're looking at a bunch of them when they walk down the street, you call us Democrats. There aren't enough seconds in the universe since the Big Bang for 1 mutation per second. It means you didn't do basic math or look that shit up. You can type in how many since the Big Bang, or how many weeks since the Big Bang, or how many days since the Big Bang. It would have taken you absolutely no fucking effort to do this. Or you could just say 13 billion years divided by 3. You already have your billion. You don't dread a creator. You dread a lawgiver and a judge. Yeah, because it's you and not your God. People like you coming to my content, coming to my channel, posting this shit, are the reason I make videos about something interesting and educational. Because you're the polar opposite.